Welcome everybody to the Unit 4.0 notes. What we're going to do here is we're just going to go over some factoring stuff, some more advanced factoring stuff. It's really not that bad. All we're going to do is solve for x and do that by factoring. So for instance, for this first problem right here, the one thing you do not want to do is distribute everything through and expand here, distribute, and then combine and solve. That's just too much work. But we can find GCFs or just basic factoring as we go through here. For this, I do see this. This is the first term right here in red. And then I have another term here in purple. And what terms are, what do these terms have in common? X plus 2 and a 4. So I'm going to pull out a 4. X plus 2. And then what's left for red? X is left for red. So I'll underline that. So you know that's left from red. And then what's left from purple? Just X plus 2. And we can combine this for x plus 2. We can simplify this parentheses right here to become 2x plus 2. Yeah? Does that factor yet again? Take out another 2. So it's going to be 2 times 4, which is going to be 8. X plus 2. X plus 1. Was that too fast for any of you? No, you're all fantastically awesome AP pre-calc students that understand that math. Now once I'm here, I'm all factored out. I can go ahead and solve by setting each of these equal to 0. So I'm going to get x plus 2 to equal 0, and I'm going to get x plus 1 to equal 0. So what does x equal? Negative 2 and negative 1. So next year when you start doing problems, you're going to do something called derivatives, and you need to solve for stuff. And then they're going to look messy. So what we're trying to do today is just make this mess look not as messy. Okay, and this is the best way to do it. All right, moving on to B. So, again, I have my red, and I have my purple. What do those red and purple have in common? Just x plus 1? Sure thing. So what's left in the middle here? X plus 1 plus... Sure, I'll underline these so we got this. Is the underlining helping us at all? No? It does, okay. It's visually pleasing? Oh, sorry, too fast? So on the video, if I'm talking too fast, you can slow me down. But the studio audience cannot. So I will now talk slow for them. So now in the inside, we can distribute this 2 to clean up the inside parentheses over here. So I'm still going to have x plus 1, and then x plus 1 for the red didn't go anywhere, but now I have plus, very good class, 2x minus 4. Is that still too fast for you? No, it's too slow? Insultingly slow? No, I heard no, it's good and a yes. No, it's good cancels out the yes. How many x's do I have inside this parentheses? 3 x's and then minus 3. Is there any more cleaning up to do here? I can factor out a 3 because it says to factor the following. So I want to factor it as much as I can. That's called following directions. Something that a lot of you don't know how to do. Okay. Oh, was that too insulting? A little? You're fine. Thick skin. So what does x equal? Yeah, so we're going to x plus 1 equals 0. We're going to get x minus 1 equals 0. Whoa. So we're going to get x to equal plus or minus 1. Cool with that? Are there any questions? Yes, in the back.
So, like at x plus 1 times 2x minus 3, would I keep taking points off by this one directly? Would I take it
Yeah, because the directions say to factor. And you're not factoring all the way through, you will lose points. It's that directions thing that we struggle at sometimes. Okay, if you hear coughing, that was not me. I'm good. but your classmates might need to take cough medicine. Or your, whatever, building mates. Well, if it's in somebody else's class.
You were coughing all throughout the test.
I was?
One.
I coughed all throughout the test?
You coughed like 5 times.
I'm getting once versus 5 times. I don't remember coughing at all. Can someone verify my amount of coughs?
It was around 3.
It was 3?
Oh yeah.
So this class is completely lying. I don't remember a cough. To be fair, maybe...
Cough, I flinched.
No, one time was really long.
God. All right. Factor the following to rewrite as a single ratio of factors. What that means is just write this out down as one fraction, and then we'll go ahead and solve for x. Ooh, we can even add on some things over here. So let's go ahead and factor. The bottom looks like it's completely factored out for me, so let's go ahead and factor the top. So I will do underlining. We like the underlining?
Yes.
All right, so here we go. We got the first term there in red. Second term there in purple. What do these have in common? X times x plus 1. Very good, class. Wow, very impressed. So, x minus 1? I'll underline a little bit here. So this is the leftover for red. And we took everything out of purple, so there's leftover for purple. Set this equal to 0. Yeah, what do we do now? Hey, this is like review now. Okay, x plus 1 and the x plus 1. What does that make? Whole at x equals negative 1? You kids these days. What else cancels out? This x cancels out with that squared, so there's also a whole at x equals 0. So if I rewrite this now, I get x minus 1 over x plus 1 equals 0. I half lied, by the way. So this is what it looks like. This is what it looks like. But really, since we still have a vertical asymptote at 0, x equals 0. I forgot to put that x equals there. And x equals negative 1. What do we actually have? Since there's a whole and a vertical asymptote. Vertical asymptote always wins. So we have vertical asymptote at, I'll write that better, x equals 0 and x equals negative 1. Let's see if that comes into play, folks. When we set this equal to 0, we set the top equal to 0, and what do we get? X equals 1. Does that interfere with any of my restrictions? No, because I'm restricted at negative 1 and 0. So I solve for x. X is equal to 1. Wasn't that such a great review problem from previous stuff? Yes, sir. I cannot name you on the video.
At the beginning, why couldn't we cancel out the x squared on the top and the bottom?
Well, you have to factor it first. You're saying cancel out this x squared with that x squared?
Yeah.
You can't do that because you can't cancel out terms. You have to cancel out factors. This is a term because there's a minus sign right here. So this is 2 terms. You need to make those into factors. Factors cancel out, not terms. That's a great question, random sir. Any other questions? Not bad, right? We're kind of going back into like normal math. What we were doing was normal math, just because like there's pies. What do I do with pies? How do I deal with pies?
Why does it
That's E, that's not pie. It's so
Yeah, but
bad.
it's so bad. It's such a random bad.
All right, here we go. Factor the following as a product of factors, and then solve for x. Let's stick with A. Oh my garage! There is quiet, folks. That kind of sort of looks like a trinomial. Watch me underline this in purple. Yeah? Yeah? Yeah. Trinomial has 3 terms. How many underlines did I do? 3. And this has a square, and that has a first power, and that has a 0 power. Some teachers refer to this as like a U substitution type of deal. Yes, a different random sir in the back that is squinting, but is capable of moving forward.
I was like, isn't it 1 though? But we said 0 or 2. I see 1 or 2.
It's still the 1 power.
This has a power 2, this has a power 1, and this has a power technically 0 because there is no variable here. I'm referring to the variable part. Some teachers will be like, all right, let's let u equal x plus 4, and they'll be like, all right, this is really u squared plus 3u plus 2 equals 0, and then you can solve for there, and that's fair. That's fair. I don't want to call this u substitution because you have to earn that. That's in calculus. You have to earn that. I think we could just look at this and just be like, oh, we have a fact. Our variable term is x plus 4. So if I were to factor this, remember double bubble? Double bubble. You're saying what? You have been lost all year. Double bubble. What two terms multiply? What numbers multiply to 3 but then add to 2?
3 and 1. 3 and negative 1.
Sorry, I might have said that backwards. Multiply to 2 and add to 3?
2 times 1.
2 times 1.
Yeah, 2 and 1. So what goes in the front right here? Do you know what? I feel like I miscolored for you. We'll go x plus 4. X plus 4. Do you see how I did the u substitution, but instead of like u, I just rewrote it as x plus 4? Okay. I mean, like, I don't really care how you do this. Like, I'm not here to like. I don't criticize you with how you do things. No, that's well, it's on video right now. No, I do not. Okay, so you can use u substitution if you want. I'll just use different colors so you can see it. So how does this first factor simplify? X plus 6. And then x plus 5 equals 0. So then we're going to get x plus 6 equals 0 and x plus 5 equals 0. So we're going to get x equals negative 6 and negative 5. All right. Oh, any questions in the video? If you do, make sure that you comment. Actually, no, this is the channel I don't care about. Oh, by the way, there is a really awesome channel, okay, that you should subscribe to. It's called Cranky Calculus. Just search it up on YouTube. There's some really awesome videos. You really should subscribe, especially if you're going to go into calculus next year. I hear that guy is pretty cranky. You know, solid videos are being made, still being made. I'm told he's on hiatus right now, but he might be back when we get closer to the AP exam for calculus. Anyway, go to that channel, subscribe, watch the videos, like. Don't just watch a little bit of it. That messes up that guy's algorithm. We don't want to mess up this guy's algorithm, all right? You want to watch the whole video. So if you hit play, I don't care if you watch it. We can walk away. You just cannot stop it short, all right? That guy can tell by looking at the analytics. A lot of people just watch like a couple minutes of the video. You need to watch the whole thing. Do not mess up this guy's algorithm. All right, moving on. So for this one, hey, this kind of looks like a trinomial again, does it not? Sure does. You can use some of it if you want, but what is the variable term? 3x minus 1. So when we go ahead and factor this, we can double bubble. What are you saying, oh my god, in the front? Double bubble?
Yeah, it's so amazing.
Okay. So what two numbers multiply to 6 but then add to negative 5?
2 and 3.
2 and 3?
Negative 2.
Negative 2, negative 3. And then I'm going to put in the front with the red's going to be 3x minus 1, 3x minus 1. So what does the first term become? Or first factor? 3x minus 3, and then we're going to get 3x minus 4. Hey, we can still factor. What factors out of this first? Look how clean this looks. So clean. Set each of these equal to 0 here. So we're going to get x minus 1 equals 0. And we're going to do 3x minus 4 equals 0. For the first one, we're going to get x to equal 1. For the second one here, if you add 4, divide by 3, you're going to get 4/3. Was that too fast? Question from another random sir. Yes?
If I put negative 3 and negative 2, we still put 3x minus 1 minus 3, 3x minus 1 minus 3.
I didn't understand your question.
He's asking if you like the negative
Oh, does that matter? No, it's the same thing. It's commutative property with multiplication. So same thing. Doesn't matter which order you do it in. We good here? We get to the things that people think are scary, like, ooh, this is scary. You know this is on the AP exam last year? I don't know if this is this exact question or not. But 0 of my students that took the AP exam last year got this question right. That was really upsetting. Of all, like, 5 of them that took it. I went 0 for 5 in this question. So, because of them, I'm now making you do it. So, trinomial. Do we see the trinomial here? 3 terms, make this into 2 factors. What is our red underline? It's actually just e to the x, because this is the same thing as e to the x squared plus 6e to the e to the x minus 7 equals 0. Do we see how this e to the 2x really is e to the x squared? Okay? So now we can double bubble. What 2 numbers multiply to 7 and add to 6?
7 and -1.
Plus 7 minus 1, and the first term is e to the x. Okay, this is skills you should even know from Algebra 2, really, and how to solve these. This is not bad. So e to the x plus 7 equals 0. E to the x minus 1 equals 0. How do you solve this left one? Subtract 7. So we're going to e to the x equals -7. And then what do? So you're going to get ln of -7 equals x. We like this answer as a class? We love it. You ready to move on? This is why we struggle in this class. What's wrong with this? That's a domain error. We can only have ln of positive numbers. Can't have zeros or negatives. Oh my garage here. You know what? You're all just acting, right? You were all part of it. Thank you. So we are going to reject, because ln's cannot have negatives or zeros inside of their, we call that an argument, inside their argument. Can't have that. That's no good. So reject. What about this one? This becomes e to the x equals 1. You can rewrite this. ln of 1 is equal to x. So x equals ln of 1. It's a great answer, but I can simplify this one. What is ln of 1? It's not 1. That's why we struggle. It is 0. Sorry. I need to save that for this other great channel, Cranky Calculus. What a great channel that is. Maybe I should start teaching this class during it to increase the crankiness. So I only have an answer of x equals 0. Okay, class, why did I reject this one? Yeah, it's under restriction. X has to be the inside, the interior part right here. The argument needs to be bigger than 0. All right, here's our last question. I totally believe in you, class. This is a trinomial. Okay, what is the u sub variable? The ln of x is. So let's go ahead and double bubble. I'm having 0 fun right now. Oh, okay. Oh, you can't say names. That guy. I'm getting in trouble legally here. Okay, this one's a little bit trickier because our a value is leading with a 3. So it's actually going to be 3 ln of x and ln of x. There's no way to avoid that, no matter what. That times that will give me 3 ln of x all squared. Use this. We need a 5 and a 1. That's when we get 5. So how do we match this up so we get a 2 in the middle? So I hear 5 here and 1 there. How do I get a -2? -5 plus 1? Does that work? Half of you are saying I don't get it. This is.
You don't get it. But how do you get -2 from that?
You're going to get 3 ln of x's, and you're going to take away 5 ln of x's. That's going to give us a -2 ln of x.
Get it.
Okay.
Okay, shut up.
This is a very long video. I'm looking at it. We're at 20 minutes. This is taking too long. So it's set each of these equal to 0. All right. So for this first one, we're going to add 5 to both sides and then divide by 3 at the same time. Are we cool with this being 5/3? And then how do we get rid of the ln? Loop it. ln has a base of e, so it's going to be x equals e to the 5/3. The same thing on this one over here. We're going to ln of x equals -1. And we're going to loop it, and we're going to get x to equal e to the -1. Any rejecting here? We don't reject nobody here. I'll just write this nice and prettily right here. Are there any final questions before I sign off this video? Alright, class, I hope you enjoyed the video, everybody. Please subscribe to Cranky Calculus. Do that now, or forever hold your peace.